All right, so you have the guided notes in front of you, and here I have several examples that I wanted to go through and maybe highlight some of the differences between conversions and some of the differences between conversions and proportions and how to solve each one and how I want you to start showing some of your work. So here, the first example, the scale of a map is 1 centimeter for every 25 kilometers. You measured 33 centimeters between Kansas City and the closest beach. How many kilometers do you have to travel to get to the beach from Kansas City? Well, the first clue that I get in this is that it gave me, the question itself gave me a ratio. Here's the ratio. There is 1 centimeter for every 25 kilometers. So I know that I'm trying to find the number of kilometers to get to the beach. So if I don't know how many kilometers it is to get to the beach for any of our unknowns, we simply say x. I don't know how far it is to the beach. And then I'm going to put that over the number of centimeters it takes to get to the beach on the map, which is going to be 33 centimeters. Now here, I'm putting kilometers over centimeters. In general, I want my unknown variable to be in the numerator, so I want x over 33. So for my ratio, the ratio that I want to let it equal, I want to put kilometers in the numerator and centimeters in the denominator. So it's going to be 25 kilometers for every 1 centimeter. And now for this proportion, everybody here should know how to solve this proportion. Or multiply both sides by 33. And I'm multiplying by 33 over 1. And the 33s are going to cancel on the left side. I'm left with x. And on the right-hand side, 25 times 33, which nobody can do in their head unless they're a little genius. And if they are, tell me what you do. 25 times 33, and the calculator says 825. All right. So that gives me, get my pen, 825 kilometers. Now again, notice, I didn't know how many kilometers it was going to be, so I needed kilometers in the numerator, and I left centimeters in the denominator. And it's equal to kilometers in the numerator over centimeters in the denominator. This was the proportion given, 25 to 1. And this is the one that I needed to create and set them equal so I could find out how many kilometers it was to get to the beach. And whenever I get an answer, do me a big favor and put a box around it so I know. Okay, so here, Kansas City is 754 miles away from Pearland, Texas. What is the distance in kilometers? Well, it tells me the distance in miles. I'm not looking for a distance. I already know how far away it is. What I'm doing here is I am converting. I am converting from miles to kilometers. So the only way I can convert is to cancel my units. Now, I need to set up a fraction, 754 miles over 1. And now, in order to cancel my miles, I need to multiply it by another fraction where I have miles in the denominator. Again, this is multiplication. So now I know my miles are going to cancel. But I want to convert from miles into what? I needed to convert it into kilometers. So I need to know how many kilometers there are per mile. And again, I will give you these ratios. I know that it's 1.61 kilometers for every mile. So here I can now cancel my meters, or miles, excuse me, and multiply my fraction. Again, we multiply across the top and across the bottom. So 754 times 1.61, again, that's not something I can do in my head. So we get our calculator out, and we say 754 times 1.61 is 1,213.94. So it is 1,213.94 kilometers from Kansas City to Pearland, Texas. And again, box your answer so I know what you found. Now here it says 76 is what percentage of 37? Of 37. Now when it asks, number is what percentage of another number, we need to know and understand which number is our base. And here the base is 37. So I want to know what 76, I'm not multiplying, excuse me. I want to know what percentage 76 is of 37. Let me say that better. 76 is what percentage of 37? So my of goes in the denominator. And here, I'm going to set this up with the percent proportion. And now I don't even need to worry about, whenever I use my percent proportion, I don't need to worry about moving my units to the left or to the right or, oh, I don't remember. I have the percent proportion, so I don't need to worry about that. And from here, we multiply both sides by 100, because that's the denominator here with my variable. Multiplying this side by 100 over 1. Whoop, 100 over 1. That's not necessary to have. Okay, and now 100 times 76, we can just add our zeros. So it's going to be 7,600 over 37. Will tell me what percentage that is. So get our calculator out here. We're going to do 7,600 divided by 37. It gives me 205.405. Let's see, we get 200. Whoa. And what was it? 205.45? 7,600 divided by 37 is 205.405. 205.405. Now again, we want to round to this digit. So we look at the next one, which is 5. And 5 makes us round up. So we go, this digit rounds up, so we get 205.41. 205.41%. Now I don't have to worry about moving my decimal because I used the percent proportion. That was the P over 100. All right. Now the wholesale price of a shirt is $18.39. The retail price is $35.99. So the question asks, what is the percent increase from wholesale to resale? Or retail, excuse me. So since I am increasing, then I want to say new minus original over the original. So I will say 35.99 minus the original, which is 18.39, over the original, which is 18.39. Now this is going to give me the decimal percentage. So I'm just going to use P again. But remember, this is going to give us a decimal percentage. So we're going to have, get the calculator out here, and say 35.99 minus 18.39. And let's see, that's 17.6, and that's divided by 18.39. So it's a 0.957041. Now, this is our decimal. We want to find out what it is as percentage, so we got to move our decimal place 2 units to the right. We say 95.7. And now this is the one we want to round to right here, this digit. Remember, 2 digits in. Now, the 4 means we round down, but I'm not going to say 0 minus 1. I'm just going to leave my 0 there. So 95.70%. And that is how much my percent increase was. Okay? So now, an anaconda is rumored to travel 100 feet per second. How many miles per hour can the anaconda move? So it wants us to, we already know how fast it moves. And now the question is, instead of feet per second, we want to do it in miles per hour. So I can say 100 feet per. Now again, this per, or the division, was already given. Feet divided by seconds. Just make this one big giant 100 feet for every 1 second. And now we're going to multiply. I want to multiply that by something. I want to get rid of feet. I wanted feet to go into miles. So let's handle that one first. So in order to cancel my feet, I need to divide by feet. And so I want to go from feet into miles because I'm looking for miles per hour. So how many feet are in a mile? Well, I'll give you this ratio on the exam if we need it, but it's 5,280 feet for every 1 mile. And now I want to multiply to get rid of my seconds. I need to go from seconds into hours. And since seconds is started in my denominator, I want to put seconds in my numerator. And I want hours. I need to have hours in my denominator here. So how many seconds are in an hour? Well, that's a weird question. Well, I know there's 60 seconds for every minute, and there's 60 minutes in every hour, which means there's 3,600 seconds in every 1 hour. So now we can go through and cancel. Feet are going to cancel with feet. Seconds are going to cancel with seconds. And I'm left with miles being divided by hours, which is excellent because I'm looking for miles divided by hours. And again, with when multiplying fractions, again, we're multiplying fractions. I can multiply across the top and then multiply across the bottom. So 100 times 3,600 is 360,000 divided by, and now multiplying across the bottom, 1 times 5,280 times 1 is still just 5,280. And to simplify this, I'm going to need my calculator. Getting out my trusty calculator, 360,000 divided by 5,280 is 68.181818. All right, so this is 68.18. Now it would be 1818, but 1, I don't really need it because that 1 is not bigger than 5. So again, keeping it 2 digits, 68.18 miles per hour. That's how fast the Anaconda travels. Boy, that's about as fast as a car on a freeway, isn't it? Again, this is just a rumor. Can't believe everything you hear, right? Well, let's see. If a cheetah can run, a cheetah does run. I looked this up on the internet, and the internet don't lie. So a cheetah runs 112 kilometers per hour, and I want to know how fast that is in miles per hour. So 112 kilometers for every 1 hour. And again, we're converting. I want to convert from kilometers per hour to miles per hour. So I want to get rid of kilometers. I'm okay with hours, but I want to get rid of kilometers, so I need to put kilometers in the denominator of my other fraction. And I want to change it into miles. And now I don't know if you remember, but it's 1 mile for every 1.61 kilometers. And now here, my kilometers cancel. Kilometers cancel. And I'm left with miles per hour, which is great. Multiplying across the top, 112 times 1 is 112. 1 times 1.61 is 1.61. And this gives me miles per hour. But I need to simplify that, and that I can do in my calculator. So 112 divided by 1.61 is 69.56, and that's going to round up to 7. 69.57. So that is 69.57 miles per hour. And now that is how fast a cheetah runs. Now, could you believe that an anaconda runs as fast as a cheetah, which is basically how fast we travel on the freeway? For me, do I believe that the anaconda moves that fast? That is a big resounding no. Absolutely not. There's no way that an anaconda moves as fast as a cheetah. That's crazy to me. So these questions that I left at the bottom, what characteristics do you see that are similar with all these problems? How can we tell if we're looking at a conversion problem? What are some things that we can make note of that we know that we're converting? And what's unique about proportion problems? So these are some things that I want you to think about. And tomorrow when you get to class, we're going to organize that information.